Okay, this is 10, 3, 10, 4 formative, and given the regular hexagon, find the measure of each numbered angle. The numbered angle, number 1, is a central angle. And in order to find that, I'm going to go 360 divided by n is going to give me my central angle. Okay, so I've got 360 divided by 6, it's a 6-sided figure, and that's going to be 60 degrees. Okay, so that's the measure of angle 1. Okay, the measure of angle 2 is half of the measure of angle 1 because we have an apothem coming from the center going up, it's perpendicular. So I take measure of angle 1 divided by 2, which is going to be 30 degrees. And that's the measure of angle 2. The measure of angle 3 is down here in the corner. This is an equilateral triangle, so they're all 60. But I want to make sure you recognize that if it wasn't an equilateral triangle, if it wasn't a hexagon, it would be 180 minus my central angle, my measure of angle 1, in this case 60, divided by 2, which comes out to be 60 as well. So that's the measure of angle 3. And that's the measure of the 3 angles in this hexagon. In problem 2, I'm asking you to find the area of a regular hexagon with an apothem of 16.5. Okay, remember 1/2 ANS is equal to my area. A is 16.5. They give me that. That's right there. Okay, a side is 16 and a hexagon is 6. So the number of sides is 6. Side length is 19. And so I take those values and go 16.5 times 6 times 19 divided by 2. And I get 940.5, and that's letter D, 940.5 inches squared. And remember, all I needed was my formula and know where everything was supposed to go. A is apothem, N is number of sides, S is side length. In problem 3, I have an equilateral, 6 equilateral triangles put together. You're planning to use a ceramic tile design of your own in the bathroom. The tiles are blue and white equilateral triangles, and the blue tiles in a hexagonal shape is shown. The side of each tile is 7 centimeters. That's 7 centimeters. What will the final shape be? Well, I've got 7, and in order to get my apothem, I got 3.5, the square root of 3, because that's a 30, 60, 90 triangle setup. And that makes this 3.5, and that's this 3.5, the square root of 3, and that makes that 7. And remember, the other part of the triangle is right there. Okay, so now I've got my apothem. I got my area is equal to 1/2 ANS, and I got 1/2 my A. My apothem is 3.5, the square root of 3. My N is the number of triangles, which is 6. My S is 7. Now, in this case, they want us to have it in terms with the square root of 3 out there. They don't have us multiplying it out. So in that case, I'm just going to multiply 3.5 times 6 times 7 divided by 2, and that's going to equal 73.5. And I'm going to put that square root of 3 on the side, and remember these are all in centimeters, and it's squared, so my answer is B. In problem 4, I'm talking about finding the regular hexagon with a side length of 8. Round your answers to the nearest tenth. Okay, regular hexagon. Remember, when we give you something without a picture, it makes it more difficult. So keep in mind, it's a regular hexagon. Okay, side length 8. That means my apothem, half of 8, and my apothem really isn't a great spot. My apothem, let's try to fix that. My apothem coming up, if this is 8, this whole thing, this is 4, this is 4, this is 4, the square root of 3, this is still 8 because it's an equilateral triangle. okay, inside that hexagon. And only hexagons have these equilateral triangles. So I have 1/2, the apothem, 4, the square root of 3, the number of sides, which is 6, and the side length, which is 8. Now remember, there's 6 of these triangles that are 8 long, and I'm really talking about the area of a triangle times the side length times how many sides there are, and that just talks about how many triangles we have total. So 4 times the square root of 3 times 6 times 8 divided by 2, okay, is 166.3 meters squared, and B is my answer. In 5, now we did this 5, and we got to make sure we're careful about the setups. Okay, I have a relationship 24 to 57, and I'm going to put that in my calculator and reduce it, divide 57, and I'm going to make it a fraction. And it is the same as 8/15, 8/19. I got to get my glasses on here. Hey, look, 8/19. So we got 8/19. This is my perimeter ratio. Now, the area of the similar trapezoid is 558. The smaller, not similar, similar trapezoid is 558. Find the area of the larger. Now, I have a perimeter relationship. I have to square that. So I've got 64, and 19 squared is going to give us 361. Now, my smaller trapezoid is 558. That goes across from the smaller number. And now I do 361 times 558, and that's going to give me 201,438 and 64x. Now I'm going to divide that by 64, and I get 3,147.46875 in my calculator. But they say find the area and round to the nearest whole number. So I'm rounding to the nearest whole number, and the nearest whole number is 3147, and it is meters squared. And that's the area of the larger one, which is right here. Now, in a similar fashion, in problem 8, I think this is problem 8, maybe it's problem 7. 6! They want us to find, if these are figures, they're similar, give the ratio of the perimeters and the ratio of the areas. Perimeter ratio is easy. Okay, I've got 40 and 15, and if I set it up as 40 to 15, 5 is in both of them, so that's 8/3. Okay, but that's the perimeter. Okay, so my perimeter ratio is either 8/3 or 3/8. I've got to consider both, but if they're talking about the perimeter ratio, you know, that's 1. So I've got 8/3 and 3/8. Let's see how they've got it set up here for me. They're doing 8/3, so we're just going to keep the 8/3 for that. My area ratio, the relation between perimeter and area, I take my perimeter ratio and I square it, and that's 64:9. So I'm looking for 8/3 and 64:9, and it's in this order. So 8/3, 64:9, A. In question 7, the area of an octagon is 35 centimeters squared. What is the area of the regular octagon with sides 3 times as long? So I've got a relationship of 1/3 for my perimeter ratio. My original is on top, my other one's on the bottom. This is my regular octagon, and my area ratio is 1:9. Okay, shouldn't say that, but my area ratio is 1:9. So I know 1:9 is equal to 35 to x. So now I go 35 times 9, and that's going to give me 315 centimeters squared is equal to my x, my other. So 315, that is A, and we're good to go. Okay, so keep in mind as we're stepping through, always find an equation, always set up your stuff, and if you have a question, reread the question, check your notes, and see if you need some more assistance. If it's before the test, I can help you out. If it's after the test has started, I can just do so much.